Okay, so I think we'll start. So hi everyone, and welcome to Introduction to Real-Time Analytics with Apache Pinot. I'm Yarden Rokach. I'm a community manager at StarTree. I'm running the StarTree community and also powering the Apache Pinot community. So I probably talk to most of you if you are friends at the Apache Pinot or the StarTree community. And if you're not there in our Slack space yet, I will shortly send the link so you can join and follow our future event, product features, any update regarding real-time analytics will probably be there. So we're happy to have you. Yeah, and I think I'll pass the mic to Mark, who will take it from here. And as I said before, feel free to to introduce yourself in the chat and ask questions as well. And that's it. Mark.
Great. Hello, everybody. So yeah, I think we've got about 55 minutes. So we'll try to do about 40 minutes talking, and then I'll leave some space for you to ask questions at the end. But if you have any questions, you want to type it, I can see all of them on my other screen over here. So feel free to ask as we go along. So we're going to do an introduction to real-time analytics and Apache Pinot. So that's the goal. So let's start with a definition. That's always a good place to start. So this is Gartner's definition of real-time analytics, or at least the first part of it. So they say real-time analytics is the discipline that applies logic and mathematics to data to provide insights for making decisions quickly. Now, the most interesting part of that is the last bit, the bit that's highlighted. So providing insights for making decisions quickly. So we kind of know what we want to do. So we want to make some decisions. So we want to do something, and we're going to do something based on some insights that we got. But how do we actually get there? And so it all starts with events. And so I guess, yeah, like if you're interested in the world of streaming or streaming analytics, or if you've ever watched any content about Kafka or Red Panda or any of these tools, you'll be aware like that one of the more common or more modern ways of building infrastructure is that we're capturing events. And events will generally be something that happened in the past, right? So to be, I placed an order on a website to buy some gloves because it's so freezing cold in London this week. I ordered something on Uber Eats. There was a temperature sensor. A temperature sensor captured like the humidity and the temperature and I don't know, the air quality like of something, and we got an event representing that. It might be I did a search somewhere. So like events are things that happen, generally some sort of action that happens somewhere. And so we got the events on their own. And what we're saying is, well, the events on their own are cool. Like it's cool to collect events, but the reason that we collect them is so that we can gain some insight. Like what can we learn from those events? And not only what can we learn from the events, but can we then do something, or can the user then do something? So in the case of me ordering the gloves, I guess there we're maybe if we were assessing those events, we were seeing like, hey, are we suddenly seeing a surge in people buying gloves? Maybe we need to do some to stock up on certain things. Maybe we're going to run out of stock. If it's someone doing a search to get something to eat, maybe we can get an advert in front of them to say, hey, look, there's a Deliveroo, there's Just Eat or whatever. There's like these restaurants who are available to offer things. So that's like everything is centered around this. It's like in like real time or close to real time, can we do something with the data? Be it like the company or the organization who's collecting the data, or sometimes it comes back to the users. And so we'll see some examples as we go along. And so when these events are collected, imagine the events are being collected a long time. So like the time is going from left to right, and the value of the event is at the most when we're on the top, like when we're right up on this left-hand side. That's when it's the most useful. Like if I'm doing real-time analytics, I'm in this sort of area of this chart or this graph right near the left-hand side, right? And the reason that we're over there is because if we want to take some action in real time, we want to be able to impact like what's happening. So if it's like someone placing an order, we want to be able to do something about that. If it's someone ordering something, we want to make sure it doesn't go out of stock. And there certainly is still value in the data as it moves over to the right-hand side, right? But it becomes historical or batch analysis, and you're probably more likely to be pushing that data into I don't know, like a data warehouse, a data lake house, like one of those type of tools where we can take a bit more time. Maybe the user or the recipient of the data is an internal user, and they're happy to wait like for a bit longer to get the result. And it's more like looking at like what happened yesterday or what happened last week, so that we can decide what to do in the future. Whereas the real-time thing is a very specific area of data, which is on this left-hand side. So who might be interested in this data? So it could be the analysts. So imagine we're running the imaginary restaurant I was talking about. So be like the operators, like of the pizza shop or like of the burger joint, like are trying to see like what's happening. Like, are people ordering things now? Like, what are the feedback that we're getting from people? What things are they buying? What things are they not buying? Are they even buying anything? It might then become the management. Like, they want to just get an overview. Just tell me what's happening with my business. Like, whatever it is I'm running, like an e-commerce shop. Like, what's the high level picture? And then equally, it might be the users. Like, can we feed stuff back to the users? So if it was a user searching for something, they want to get like a good result, right? They want to see like a useful information coming back. If it's someone maybe buying something on a Nando's, like on a restaurant, they want to be able to see like what other things should I be buying? Like, what have recent people been buying? Like, what's a good thing, like a new thing on your menu? Like, what are other people getting? So like, can we use the data that's just happened to feed into the users? If it's I guess if it's like a website, a social network or social media website, can we put like the data in front of people that they might be interested in, that they're going to interact with? So this is like feeding the data that they created back to them to try and like make it a bit stickier. And so let's just run through some examples so maybe we get the hang of what we're talking about. So LinkedIn is quite a big advocate and creator of real-time analytics use cases. So one of the most, I guess, used one of these is the who viewed your profile. So I'm sure you've seen this on your profile page. You can see, like, even if you are just a normal LinkedIn user like me, you can see like, hey, look, this is many people viewed it. And sometimes it will give you like a list of the most recent people. And if you are a premium member, I think you can see every single person. And so you could, if you were using LinkedIn more professionally, you could go and then see like, why are they looking at me? Like, is there some collaboration I can do with this person? And maybe like react to the fact that someone is looking at your profile in real time. I don't know, maybe they are interested in hiring you for a job or consulting with you on something like, but it's like maybe it's like a timely thing. And so being able to know that someone is interested in interacting with you is useful. So you can then see on the right hand side of this picture is sort of showing the number of users who are using this, and it's very, very high volume, right? And I guess that's the other thing that when we're feeding it back to the users, in this case, like the users of LinkedIn, whatever system we come up with needs to be able to operate at high throughput and low latency. Another one would be the newsfeed. So imagine here we've got like the actual more or less the same as Twitter, the same as what Google Plus was like, the same as pretty much any newsfeed would be. It's like stuff, like they're putting stuff in front of you and they're trying to show you stuff that you will be interested in, and they're trying to take into account what are you interested in like now, like what have you just been interacting with, like have you been commenting on stuff by a certain person? Okay, let's put that stuff at the top. Do you always like things by a particular user? Okay, let's get that stuff at the top. And they're trying to get you to interact with stuff, right? They want you to like things, they want you to comment on things, because then that makes the person who posted it feel good about their content, and then they're more likely to go and do the same with someone else. All of this is around, can we make people use the newsfeed more? The talent pool report is another one. So here, this is like actually more of a narrow set of LinkedIn users. So this is for like people who are using it for like recruitment. So they're getting like a view of all the people who are changing jobs, all the people who are, I guess, in the whole database. It looks like we've got 266,000 in here, and then they're getting like what's happening, like who's hiring now. I guess right at the moment it would be like which people are becoming available. So can we like move those people who are unfortunately like working in very big tech companies who are trying to cut down their staff? Like, can we get those people into maybe some of the smaller companies? Like, which ones would be the best fit for those people? Like, depending on their job title, perhaps depending on their location, perhaps depending on the specific skill set. It's often in scaling like really big, like distributed systems, right? Like there's very, very few people, like fewer people who can do that, and but some places who need it. So like, can we connect those people in real time together so that they don't have to wait too long, and maybe they can sort this out before Christmas next week. Another one, let's have a look at, is Restaurant Manager from Uber Eats. So this is the dashboard that each of the restaurant managers will get. So if you put a restaurant on Uber Eats, you will see this type of screen, and it sort of shows you, it's kind of interesting because it's showing some real-time data, so i.e. like what's happening right now, what's my revenue coming in right now, but you're also able to compare it to what happened this time, like in the last 12 weeks. So I can see, like, is there a change in the trend? And so you could imagine you could feed this into some sort of anomaly detection system. Like, are we seeing some change, like in what's happening? Like, are we suddenly seeing a dip in the people who are interested in a pizza? Probably, hopefully also taking into account, like, hey, people are not always going to want pizza at certain times of the year. Maybe they're like around Christmas, I suppose. Maybe there's potentially less interest in pizza on some of those days. And what's most interesting about this one is that it has some things where the restaurant manager themselves can do something really like actionable, like in real time. Like, and this would not really work if we put this like the missed orders or the inaccurate orders or the menu feedback. If we put that into like his batch analysis, like if we did that in a data lakehouse or a data warehouse, maybe we can find out, like, okay, yeah, we missed some orders, and we can see like the trend of what we did with the orders, and okay, we want to try and set a goal of not missing orders. Okay, we are generally improving. But in real time, what we could do is maybe we can actually fix the problem. So, hey, we've missed this order. Let's go and get a discount coupon printed for this person. Let's call them up. Let's contact them, and let's see if we can sort the situation out so that they don't like stop using Uber Eats. Right? That's the benefit of what we can do if we can react to data quickly. And with all these applications, they are generally building these applications using some set of tools. And so I want to just give you a quick crash course in what my friend Danushka calls the real-time analytics stack, or the modern streaming analytics stack. And it's kind of like just a way of categorizing these tools that you will see that are needed to produce like those systems, like the Uber Eats, like the LinkedIn, like some of the other examples that I've been talking about. So we're just going to quickly go through them, and then that will help us to set the context or set the frame of what exactly is Apache Pinot and how does it fit into this ecosystem. So the first thing is we need event producers. Like, if we don't have any data, then we can't even build anything. So we've got some event producers, and they're going to put some data into the streaming platform. So where do the events come from? So there are generally 3 places. So the first one is maybe it's an existing OLTP database, or it could just be any transactional database, right? I put OLTP, but it could be anything. It could be MongoDB, maybe it's MySQL, maybe it's Postgres, whichever one it is. Like, generally, like the ones that's been there for ages, like could be Oracle, and they've collected all the data, and still it's going to be used, and it's going to be there forever. Like, no matter how many new NoSQL or new real-time streaming or streaming analytics databases come along, this one is still going to be there because it's reliable. It can handle the scale of what they're doing, and everybody trusts this one. And this is the source of truth of the data. And so a common architectural trend has been that can we decouple transactional workloads from analytical workloads? And so then the problem becomes, okay, how are we going to get the data from the transactional database into the analytical database? And so we generally use like some sort of change data capture tool. So Debezium is a popular open source one, but there's also tools like Flink CDC and stream processors like Quix have tools as well. So there's a bunch of different ones. And so the idea is, can we get like an event stream that represents the stuff that's coming in on our existing databases, and then put it into a streaming platform, and then move it down and do something with it further on? So that's one type of data. Second one would be like, are we running a website or a mobile app? There are events happening on there. So like, I don't know, someone clicked on something on the page, someone navigated to view an article on the BBC website or on the CNN website. Somebody filled in a form. They're all logged in. Like, all these things are captured by events. Like, in the simplest one of these would be Google Analytics, right? You put Google Analytics on it, you can actually wire it up to capture events like this. And then if you get to more fully grown solutions, you end up like using something like Twilio's Segment or Snowplow, and all of those are generating loads and loads of events for you. Like, at the simplest, it would be like, imagine you're capturing like a log entry of, hey, somebody viewed a page. But as we go to more complicated stuff, it's maybe capturing, it's got like a JSON structure representing that event. So that's another type of event that we could use. And then finally, we can literally take any data source, and as long as we can get it into, like, process it with a language SDK of some sort, like popular ones, Java, Python, Go, Node, I guess more recently Rust. Like, is there a tool that allows us to publish the messages to these streaming platforms? And then it can be anything, right? It could be, hey, I'm scraping data of a website, I've got a feed or an API coming in. I'm going to feed that API into my streaming platform. So that's how we get data into the platform. So what is a platform itself? So streaming platforms are generally, they're ingesting data from one of those sources, and they need to be able to do it in a scalable way and store it durably. So we need to be able to store some sort of, often like in a topic is generally the the common way of representing this. And a topic would be a type of streaming data. So like it would be some sort of event. So I'm capturing my orders are on one topic, my users are on another one, my products are on another one, like all the different ones captured in so that they're kind of capturing one type of data in one topic. And they're usually using some sort of log, like a distributed log. So it's kind of like a way of thinking like this is like just capturing like each of the events almost in an infinite stream of data. So imagine each one of these. So each one of these is representing one event. So like full, and this is an example of like a Kafka topic, and a partition means just a chunk of the data in that topic. And so the idea here would be that we want to be able to partition this log across multiple servers so that we can scale it. And so we've got some backups if one of the servers crash. And like we can think of it as like an infinitely long log, but generally like it will be truncated at some point, right? Like at some point they're going to go, okay, like, we're not keeping this data for more than, I don't know, 7 days, let's say, and we're going to truncate it there, and we're just going to aggregate everything up, and we're going to whatever we wanted. Hopefully we've got that downstream somewhere, because now we don't have it in this streaming platform anymore. So that's the streaming platform. So we've got the data, we've got the event producers, and those are putting it in the streaming platform. So now what are we going to do now? So the next thing we could do is we've got the stream processor. And so sometimes you might find you don't need the stream processor, but sometimes you might find that you do need it. And so what it does is that generally the events are coming in, and they're coming in on an input topic. And what the stream processor is doing is it's doing some sort of operation, and generally it's producing like something onto another topic. So for example, let's say, imagine we get some events coming in representing an order, and maybe on the order they've only got the product ID. Like maybe on the website it's just got the product ID, and so it was captured by the event tracker and it was passed into the order stream. And then lucky for us, we have another stream which has the products which have been populated using the change data capture from our Postgres database, and we're going to do some join. We're going to do some joins. We're going to join the users and the products together, and then we're going to have like almost like an enriched orders stream, and we're going to send that onwards to someone else. So it could be we're doing a join. It could be we're creating like a materialized view. So hey, we've got this data in some disparate sources. Let's make a view of it, and then we can pass it on. Maybe we're doing streaming ETL. Maybe we're doing some sort of window operations. We just want to capture like what's the aggregate of stuff that's happening like in a certain period of time. And when you're like the users of this data don't necessarily have to be real-time analytics. So it could actually just be streaming analytics. So maybe we're building stateful aggregations or window operations, or as I say, materializing streams, and then we're using like some downstream is just processing that data. It could be we're building some microservices around this. So you'll often see like stream processors and streaming platforms being used to help to decouple the microservices, because generally you don't want like microservices to be using the same database, but it's fine if they are using data that's maybe coming from the same sources, as long as it's kind of being decoupled through this type of tool. So maybe we're building like some sort of event-by-event processing or reactive logic execution tool, whatever it might be. So both of those ones don't actually need the serving layer, which is the next piece that we're going to look at. But the last one does. So the streaming ETL. So we're kind of using the stream processor to do some like real-time ETL rather than like ETL on the events as they're coming in. So we're doing some joins. Maybe we're filtering it. So imagine there's some events coming in and we're not really interested in them if they are, I don't know, if they have a particular type. We're just going to go, okay, we're going to pass those down. We're not interested in those. It could be like, hey, the stream is coming in, but the way that it's partitioned, it means that it has way too few partitions. So we can't then process it downstream in the serving layer like fast enough, right? So we might want to do some repartitioning, choose some new keys so that we can split it up into more partitions in the streaming platform so that we can ingest it faster when we go downstream. Okay, so that's so far, right? We've got the event producers, the events coming in. Optionally, we have the stream processor doing some stuff. Potentially, then that's where it ends, right? We could just be doing streaming analytics over there. But sometimes we then need we want to be able to do, to actually go and store that data somewhere else and do some queries on it. And so that's where the serving layer would come into things. And so it's possible to go straight from the streaming platform to the serving layer, but optionally, as I say, we can do the stream processor. And so these serving layers, what do they need to do? So they're generally OLAP databases, and there are a few key properties. So the first one is the data needs to be really fresh. So we want to be able to get stuff that just happened in our streaming platform. Like it's no good like knowing like having a delay here. Like it needs to be fast. Second thing is we want to be able to query it. So we want to be able to get it in and query it quickly. And those two things need to be decoupled. So we should be able to still query on stuff as it's coming in. And then finally, which we kind of saw in the LinkedIn example, it needs to be such that these things are decoupled enough and scalable enough that we can then do lots and lots of queries per second on them. So we want to be able to do tens of thousands or maybe even hundreds of thousands of queries per second. And then ideally, like on top of that, we want to be able to do complex queries, maybe joining things together, doing aggregations, doing filtering, and be able to operate on big data sets of stuff quickly. And in order to achieve that quickly, it generally means there needs to be some sort of parallelization behind the query engine. So that leads us to Pinot. So Pinot fits into this serving layer. So what is it? So it's an OLAP data store for real-time, low-latency analytics. So it's kind of optimized for this. It uses columnar index storage. It's distributed, like kind of meets the criteria we talked about. It partially uses the Lambda architecture, so you can load in batch data and combine that with the real-time data, although in this particular talk, we're only going to be focusing mostly on the real-time data. And then it's accessible via SQL, and there is, it is open source with the Apache license. So this is a diagram of like kind of what it looks like, I guess in some way. So we have events coming in, and the sources are sitting on that left-hand side. So it can be some sort of streaming service, as I mentioned. It can also be some sort of batch service as well. So it could be loading data in from Spark, or we could be loading it in from an S3 bucket, whatever it might be. And then it sort of can build aggregation. You can do queries on it. You can build indexes on it. You can do some sort of pre-aggregation, which we'll talk about later. And then just on the right-hand side is some of the reasons why you might be wanting to do that. So let's just have a quick look at the architecture of how we are achieving this. So this is the architecture of Pinot. So there are, like at a high level, three components that we need. We've got the controller sitting on the left-hand side. So that's the manager of everything. So it's kind of taking control, like taking care, like what is in my cluster, where is all the data, like keeping track of the metadata. It's using Zookeeper and Helix. This is some tools, or Helix developed that as a tool developed at LinkedIn as well, to take care of like the metadata around the cluster, and like, hey, that segment or that bit of data that came in, it's on this server, and it's also on this server. As I mentioned, there's then servers. So we've got real-time servers and we've got offline servers. And so offline servers would be, hey, we are loading in data from S3. We're loading in data from Hadoop. We're loading in data from the Google Cloud. And real-time would be, hey, we're loading in data from Kafka, Red Panda, Pulsar, whichever one we want. Over on the above that, we've got the broker, and the broker is where the queries come in. So the queries are coming in from a client. It could be a driver. It could be the HTTP API, one of those. And generally, what will happen is the queries come in, and then they are scatter gathering out. Like the broker knows, like, okay, where do I need to? Who's likely to have the data to answer this query? I'll send it out to all the servers. They will send back the answer to their particular bit of the data, and then the broker is doing some aggregation on top. So it's kind of like a bit of a combined effort between the server and the broker to give you the query result. And then finally, we have an extra optional component, which is the minion. And this is sort of used if there's some like high computational load tasks, and we want to run them. Like, for example, let's say we are polling an S3 bucket, and we want to check like every, I don't know, like we got a cron job every 20 minutes. Is there some new data that I want to bring in? We could use a minion to go and do that job. And so it saves us putting the load on the other tools, but it will still be like that. It will still then feed the data in and become available to one of the servers in that particular example. So that's the architecture, and it's generally very plugin based. So if it's just I guess this is more for the curious. So it's very much designed around making it possible to add in new file systems or new input formats or new instances of the client libraries of streaming tools or batch ingestion tools. And so I'd say like less users do this, but if there was like a tool that you wanted to integrate with and it wasn't integrated with, you could, there are like APIs, like Java APIs that you can go and implement and then drop it in yourself, and then it would be possible to ingest from one of the ones that isn't taken care of. But I would say like at this point, mostly people are using what is there, and a lot of the common tools, like in terms of batch ingestion or like integration, like with those sort of tools, And equally with the streaming tools, a lot of it is already there. So not necessarily that you need to write it, but it is designed in a way that it's reasonably easy to do this. Even for like some of the indexing, like there is like a reasonably easy to follow API that you could, this is starting to get into like quite detailed like work, but you could write your own indexes in there as well. Let's have a look at data ingestion. So this diagram kind of shows like the whole picture of data ingestion. So it's a bit complicated. So let's simplify it. So when we're doing batch ingestion, this is what is happening. So imagine we got some raw data down here on the bottom of the diagram. So down here, let's say it's like a file in S3 that has a bunch of JSON lines, entries. So we'll create like a batch ingestion job. This will get ingested and it gets written into what we call the deep store, sometimes called the segment store, but more often the deep store. And this is like the source of truth of the data in Pinot generally belongs in here. And then what will happen in this case is the controller will know, hey, I've got some data here. It will tell one of the servers, hey, you need to go and download this file. And it will, so what it will do, it will be creating for each, say there's 10 files in S3, it will be creating 10 segments in here, and they can be downloaded like probably into multiple different servers, right? Some servers will have the maybe first 3 segments, the other one has the next 3, and the other one gets the last 4. And so that's like kind of the overview of how batch ingestion works. Streaming ingestion, slightly different. So the data gets streamed, it's coming in here. We keep track of while the data is being ingested. It's like a kind of keeping an in-memory copy of the indexes, but a locally stored copy of the actual data itself. And we call it a committing segment. So it's almost like a mutable segment, like it's in process. And once we reach a threshold, like I imagine we set it up when you reach 100 megabytes, I want you to create it, like flush it and create a new one. Once we reach that point, then we're going to write it to the deep store. And again, this is available. Like if you wanted to go and look at it, like you could download it from S3. I mean, it would be kind of difficult to read because it's like using a custom format, but you could if you wanted to. And again, as I say, lots of different tools can be used to stream the data. So that's the data ingestion. So you can kind of see the whole picture. So we can ingest batch data and stream data. They look the same once they are ingested. The mechanism is slightly different for ingesting it. But you can then query it as if it was the same, right? You just see like, hey, there's a table with some stuff. So how does query execution work? So I mentioned that where the queries come into the broker. So that's like part number 1. The broker will then forward it to whatever the name of the servers are, to the servers of the table name that the query was executed against. So it could be, in this case, a real-time and an offline server. The server aggregates the result for its segments, sends it back to the broker. And then, as I say, the broker aggregates it, sends back the response to the client. So what I want to do now, I want to show you some demos. Now, if you've never used Pinot before, this is a pretty good, I'd say this is a pretty good place to start. So there are a bunch of quick starts that come with Pinot. And what these ones do is instead of like making you have to go and create like some sort of Docker Compose configuration where you've got your controller and your minion and your broker and your server, all of these are just run in memory on a single container. So it's not for production, but it is very helpful for getting up to speed. So if you're using Docker, you can call Docker run, and then this is the port where the controller lives and where the UI lives. So I just make that available to my host, and then we give the name of the image. Now, one thing that was added on I think it was somewhere on the 0.10 series, is if you're using a Mac M1, you need to put this prefix on here. Otherwise, it's super slow and sometimes doesn't even work properly at all. So you need to put this prefix. If you're just installing locally, then you don't have to worry about that. You can just call like bin Pinot admin.sh. Let me just quickly show you what is on this page. So you can, if you want to, maybe I'll post it to Yarden as well, so she can post it if you want to have a look at it. So let's have a look at this page. So what this page is, it kind of just explains like what do we have. So we have like a batch one. So this is doing like some baseball stuff. We've got a batch JSON one. So this is doing GitHub events. We've got, oh no, where's it gone now? Yeah, I zoomed in too much. There we go. We've got streaming with minion cleanup. This is a GitHub. We've got upserts. So upserts is like, hey, I want to only keep track of like the latest version of something. We've got hybrids combining the 2 tables. And so what you can do is if we copy this, or if I go to my command line, if I do the quick start and I type in help, it will show me like all the options that I have. So you can see if I highlight here, these are all of the quick start. So you could do empty, doesn't have anything, or you can pick one of these to work with. So let's start with what was I looking at before? Let's have a look. So let's do batch. So if we do batch, so this is the simplest one. So what it's going to do, it's going to start it up. You'll kind of see some of this going by. So you see it saying, hey, I'm starting Zookeeper, the broker, the server, the minion. And then so all of these are in one JVM process within one container. We'll get some messages. Hey, the broker is ready. The server is ready, or the server is in process. The minion is starting up. We've got, I guess that might be the server. And then after it's done that, it starts to bootstrap the table. So you can see it's loading in a bunch of data. And what we'll do now is if we come over to, let's just replace this one with localhost 9000. So you can see here, this is an overview of what we've got in our cluster. So we've got one controller, one broker, one server, one minion. All of these are in memory on the set. You can kind of see they've all got the same host, right? If we would have created like a bunch of different containers for each of these, maybe running on the same network locally, you'll see different IPs than what we are seeing here. Right? At the moment, everybody's on the same one. You can then click on it. So we could go and click on the controller and it will show, hey, look, here's some metadata about the controller. It's not that interesting, to be honest. The more interesting thing to look at is, hey, we got some tables. So you can kind of click on here and it will show you what tables do you have. So hopefully it's big enough. Yeah. So you can see we've got airline stats, we've got baseball stats. We've got dim baseball team. So what this means is a dimension table. So this is like just like a lookup table. We got GitHub events and we got Starbucks stores. So and most of them, they got one segment. Only the airlines has got 31. So if we click on airlines, you can kind of see you get like a bunch of operations that you can do on the table. We've got the schema. So this is the schema of the table. So you can see we've got like a bunch of information about airlines. So we've got the elapsed time, we've got the airtime, delays, loads of different stuff, right? So there's lots and lots of different things. And then over here, we've got the table config, which is where you can kind of control like what indexes are there, what sort of encoding is being used. In this case, it's using a timestamp index, which we created a video about last week. And then it's got a couple of transformation functions. The transformation functions are when your source data, like the data that's coming in, is kind of needs a little bit of tweaking. Like it's not quite enough to require a stream processor, but it's enough that it's not in the right structure for what you want to store in Pinot. Now, if we then click over, so that's kind of the overview of the tables. And then if you come down here, you can kind of see like, okay, this is one segment. Do we have? So it gives you like a bunch of metadata. So, hey, this segment has 289 things in it. It will tell you, I think it might even tell you where it came from. So you look here, say, look, this is where the file was ingested from. So it was in airline stats Avro file. Okay, so it's kind of interesting, but what's more interesting is having a look at the data itself. So if we come over to the query console, we can go and then query each of these. So we can click on them. We can see like, hey, what events do you have? So this has got like a bunch of, this one is kind of probably got more, yeah. So this has got like a bunch of information about Git commits. This one is Starbucks stores. We can do then airline stats. So what we could do is we could say like, you can do things like, hey, show me, let's see if we can find an airport name somewhere. So which column has the airports? Let's see. So we've got the carrier. Hey, okay, let's do carrier. So carrier, and then let's say what's the average, maximum carrier delay. And so this is usually, it supports the calcite SQL parser. So it's not, I was saying, yeah, not at the moment, not completely satisfying exactly what you can do in SQL. Like, for example, right now, you can't do joins, but there is a new like kind of beta query parser in which you can do that. But I don't have it enabled for this demo. So let's just, we can do. So you can see like the biggest delay was on UA. I guess that's the United Airlines. FL, UV, EV, MQ. We could put the minimum one as well. So you can do sort of all, like, this is kind of the sort of stuff that people use, right? They're doing sort of, I guess this might show minus. Yeah, we need to say maybe where carrier delay is greater than or equal to 0, because some reason it's got a bunch of minuses. Yeah, so it's always 0. So that's not so interesting. Like, I guess they often have minimal delay. But we can kind of do queries on here. With the baseball one, I guess we can even do like a lookup if we wanted to do some sort of like in-memory join. So say we've got team ID on there. So we can, so what's it called on here? So team ID on here. See if I can remember what's the syntax. So we want to say dim baseball teams. And then which way around is going to be team ID. That'll be, no, that'll not be it. Hang on, let's have a look. Let's see if I can remember what's how exactly to do this. I think we got it on here. Have a look. So look up. Where is it gone? Should be, here we go. Let's copy this one. So we want to find, let's go to team ID. Oh no, it must be with a capital D. And then what we want to do is we want to look it up in the dim baseball teams. And there, what was it called in there? Well, it's called team name. So team name based on the team ID being the team ID. Yeah? What did we do wrong? Team name, team ID. Yeah, it should be right. Oh, I think maybe it's the D. There we go. So you can do like some basic joins. So this is all in memory. So it's kind of going and seeing it. Hey, can we find like a matching entry in that other table for the team ID? And perhaps we would want to do distinct on this because otherwise we're kind of doing the same thing over and over again. So it's not got all of them. So maybe we're going to say where name is not null. Can we do that? No, where name is not null? Yeah, maybe not. No, really. Yep. My name is null. I don't know why it doesn't like that. Apparently, I'm not going to get this right, so let's just abandon it for the moment. But yeah, you can kind of see like we can do some sort of queries on this. There are other ones as well. So if we kill this one, maybe we can scroll up a little bit. Where's it gone? No, it's quite a lot up. So maybe I'm going to just run the help function again. So those ones were shared. Those were all examples where the data has been batch loaded. We can also get ones where the data is being sort of loaded in as we go. So if we pick one of these streaming examples, so let's do stream JSON index, say. So this one actually also runs a Kafka in memory as well. So obviously you're never going to do this in real life, right? Like, this is purely for making it easy to get started rather than as a production approach. So we'll give it a few seconds. Oops, what did I do? Server's ready. And it's going to load the data once it's got everything up. So other than these quick starts, we also have some examples of demo apps that you can look at. So for example, this one here, these are kind of more full-on things. So I'll send you then the link again in the chat. So for example, this one is kind of is sort of, I guess it's a bit more than an intro. So this is sort of showing a pizza shop application, but it's using like lots. So it's bringing in kind of multiple data sources. It's also then joining things together. Yeah.
Sorry, what do you want me to do with the link?
If you can post it so people can click on it somewhere.
Of course.
Yeah, like that. So like this demo one is obviously much more full on than what we're doing, which is everything in memory. It's taking like it's got like an order generator. It's generating a bunch of orders. It's then using Kafka streams to do a couple of joins. It's using a CDC sitting here, like a Debezium to pull data out. So it's like kind of bringing in all the different tools. But if you want to have a look at an example of doing that, this is a good one. And then I also have, again, not really but another interesting thing to look at is this Pinot Wiki example. So if we don't have any questions, I can also show you this. But what we're doing here is we kind of got everything set up in a Docker Compose, and it's building like a real-time dashboard on top of Wiki streaming data. But if I come back here, just so we can see, so this one here, it's like doing this one is doing like imaginary meetups. You can kind of see it's loading. It's loading in those meetups. If we then go to the meetup table, so it was this one, isn't it? If you look in the config, the config will contain, actually, let's just do edit. It might be easier to read it. You can see we got like a Kafka or connection string to Kafka Zookeeper, which is then looking up. Well, then we also have a Kafka, a link to the Kafka broker. We've got the name of the Kafka topic, and we've got some other information that we are telling it how to read information from Kafka. So this is how it works. If you are streaming, you generally have to have some sort of streaming config embedded here. Are there Helm charts? Yes, there are. There are Helm charts. So Pinot Helm charts. So these ones would be kind of sitting in here rather than on a Docker. So although I guess as you probably imagine, they are using the Docker, but then there's a Helm sitting on top of that. And then it has sort of work examples of how to get it running on different clouds as well. So if we come back here, so this is the setup, and then you can kind of see, like as we are running it, you can sort of see more and more stuff is coming in. And again, for this data, it's creating segments the same as what was being done. But what it does is we have one segment per partition. So in this case, this Kafka stream has 9 partitions. So there are like almost nine concurrent threads bringing in the data. And at the moment, they are all consuming, right? This one's reading, I guess, from partition 0. So it's at offset 1. If we look at the second one, it's likely going to be in the same place on partition. Oh no, this one is on starting offset 4 on partition number 1. And that's basically how it works, right? So I wouldn't say like this data is particularly interesting, but this is more or less how it is ingested. And so these ones, you can kind of see more data is coming in certainly for some of them as we are sitting here. So I'm going to go back over to the slides again now. So just to quickly run you through some of what we've seen. So how is Pinot storing the data? So you kind of seen, right? Like it's storing segments, and segments are storing, it's every single column, but a subset of the rows. So like, and sometimes referred to as document IDs. And the way it's then stored is that inside each segment, we have the raw data, and this is all stored as columns, right? So we store all the countries, in this example, all the countries next to each other, all the browsers next to each other, like it's all, next to each other being like sequentially in a file. And then we can apply indexes on top of that. So by default, like everything's almost in a column index, if you like. So we can do like aggregate queries quite easily. And then there's like all the kind of common things you expect, like a null vector, range index, Bloom filter, blah, 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 all the different ones, JSON index. And let's just run through some of them. So like these are some of the common ones that we find people using. So we have an inverted index. So what does this mean? So like it means that we're just flipping things around. So like rather than going from the row to the value, we're going from the value and hey, here's all the rows. So it would mean, like, for example, like we would go through all the values in one column, like country, and we're going to make like a little map or a little dictionary, and we're going to say like what are each of the unique values, and then we're going to map them to the document IDs or row IDs that match that value. And it means that when I say, hey, I want to do a query that finds things that have a country of US, it just goes, okay, I'm going to go into my table, get the ones that have US, return them, done. So I don't need to look at everything else. Whereas if I don't have that index, I've got to scan everything looking for, is it US, is it US, is it US? And because of the way it's structured, like we're not having to go and look at every row and go into the row and figure out exactly where that country column is. So that bit, like a bit of work is saved versus if we were operating with a row store. And obviously, like this is optimized for doing aggregate queries. If you do select star, like you're just getting all the data, obviously you're kind of not really getting a benefit from using a column store. But mostly what people are doing is I want to aggregate on some column, grouping by something else. And that's the type of thing that column databases are really good for. Now, this type of index works well when you have quite low cardinality. So low cardinality meaning you don't have too many different countries. Like if every single row has a different country, which would be kind of difficult to achieve, it's pointless, right? You're just going to have a map that has an entry with country and one document ID. It's like no point. You gain nothing. So the more, almost more duplication, if you like, that you have, the better this index is. We then have things like the sorted index. And so Pinot will actually try and apply this for you on every single column that it can. When it's a batch, it will rely on you doing some sorting beforehand. So either in like Spark or whatever other pre-processing tool you're using on the batch data. For real-time data, it will do it for you. So it gets the data in, and then whatever structure it's in, it will see, okay, which things can I are currently sorted, and it will then apply a sorted index. So what's the point of a sorted index is that it allows you to reduce some space. So for example, imagine but what it means is we're going to put all the things that are the same all next to each other. So imagine that country table again. We got the US, we got Canada, we got Japan, we got US. Again, we're going to make like them all next to each other, and then we're going to create another map. We're going to say, okay, if it's Canada, then that starts at document 0, and it goes up to 80. And it means that if you ever do a query like saying, hey, find me the things that match that value, or count me the things that match the value, I just go, okay, well, I know it's 0 to 80, get me those things, done. And I can ignore everything else. So it's pretty neat like that. And then like one unusual index, I guess maybe slightly different than what you may have seen in other column databases, is the StarTree index. That's kind of the name of the place, as Yarden was mentioning where we work. And this is almost sitting in between, like doing like some sort of like cubing versus doing indexing. So it allows you to kind of choose like how much indexing do you want to do? Like where do you want to, like how much do you want to index? And you generally choose like sort of how much latency you're happy to deal with for each query. So you kind of say like, I want when you navigate, so it builds you a tree. Almost like a random forest. Goes, hey, I'm going to look at the different dimensions that you're giving me, and I'm going to build like a little tree, and on each root of the tree, I've got some like set of document IDs that I'm going to have to search through, and you basically choose, like you configure how many do I want to query. So you could say like, I want the maximum that you query on any query to be 1 million rows. And so if you did, and let's say you did, and then another person, like let's say on another instance, we said, I want to configure it to do 100,000. And so on the 100,000 one, maybe the queries are going to be a little bit quicker, but then we've chosen to take up a bit more space, right? So we kind of got to choose where on this curve do we want to fit? Like do we want to go pure all pre-aggregation, pre-aggregate every single column? So you can also say which columns should be pre-aggregated, and maybe we're going to do some counting on those. All the way up to indexing, where we're saying, actually, I want to keep all the raw data and then do something else. Does everyone else see Alex's question across the bottom of the screen share? Was the question, Edward, the one about Helm charts, or was there another one? So Helm charts, I think Cyril put the link. If that was the question, if there was another one, tell me what it is. I didn't see anything. It then does some optimizations kind of all the way down the stack. So kind of at the top level, as we just talked about, like doing pre-aggregation or like configurable pre-aggregation, sort of down to filtering. So being able to use the indexes when we're filtering stuff, being able to use the way that we store the data inside the segments, all the way down to the storage. So can we do some sort of compression at the storage layer so we're not taking up more space than we need to, and then equally like down to the level of the query planner where it can work out like what's the optimal way to query this data. So I just run through. So like the Pinot community has got lots of people. So if you want to get get going on any of this stuff, there's lots of people to help you. I say, like, people are really, really kind, like helpful. Like I find when you go in there, if you get stuck on something, somebody will be able to help you to do something. I've still got a few minutes. I'll do any questions. Otherwise, I can show you one of those other demos. If you want to come and join us, like StarTree AI Slack is where we are. If you want to look at videos, there's lots of videos. We recently did something called the Real-Time Analytics Summit, where there are lots of people from that stack, from that stack that I showed you in earlier. There's people like from Decodable, from Red Panda, from all these different people showing, and then plenty of people who work in the StarTree engineering team showing like how to build different parts of this stack. And then we've got dev.startree.ai if you want to learn about Pinot, or if you want to learn about Third Eye, which is a tool for doing. I'm sort of doing like machine learning, or no, I forget what the name of it is. Like sort of building on top of real-time analytics. So Cyril can tell us like the proper name of what I should call it. But there's like lots of content. He's written loads of stuff in there. So if you want to learn about like how to do that, maybe I'll quickly show you what it looks like. So so this is what the StarTree AI. So you can see we've got some videos done by Tim. So you can kind of see those. We've got loads of guides. You can see here's a nice picture of the community. I think this was from the 2021 call. Yarden did the 2022 one a couple of days ago. We've got to get a new picture.
You're right. Although I'm there, so I'm relaxed. No, I'm kidding.
And then you can come in here and you can see like, so this is like all the Third Eye stuff. So we've got like an anomaly detection, monitoring, and interactive root cause analysis platform. There you go. I was never going to remember that. So there you go, Third Eye. So if you want to play around with any of this, then you can take a look at that. Cool.
Thank you.
So I'll give back to Yarden then.
No, I interrupted. You wanted to finish. No,
that was it. That's the last one. Look, there's nothing else.
All right. So thank you, Mark, for this great intro. I learned a lot, and I hope the other folks here as well. From what I see in the comment, they sure did. So yeah, Third Eye is great, Robert. It's true. Guys, we'll meet you in the chat. Feel free to join the event channel, ask us questions, reach out to Mark. I volunteer you, Mark, and also reach out to me with any question. The recording of this talk will go up to YouTube soon. And thank you for joining. Stay updated for the following meetup. We'll have another meetup with Mark, deep dive into real-time analytics with Apache Pinot. So stay tuned. We will announce it on in our Slack and also in meetup.com. So thank you and have a nice day. Happy holidays. Bye-bye.